Hey everyone, in this final part of the Simplifying Rational Expression series, we are going to talk about how you add and subtract rational expressions, which is of course related to how you add and subtract fractions in general. So as a reminder, when you add or subtract fractions, you have to make sure the fractions have a common denominator. Keyword there is common denominator. Once they have a common denominator, you can just combine the numerators, such as if I gave you what is 1/5 plus 2/5. What this is really saying is you can kind of think about it as I have 1/5 and I had 2 more fifths. How many fifths do I have? So the denominators are exactly the same. They're both 5s. You would just add the numerators. 1 plus 2 is 3. Or you have 1/5 and you had 2 more fifths. You have a total now of 3/5. That's how I think about it. Okay, adding fractions is fairly simple when they have a common denominator, but if they do not have a common denominator, you must convert them to an equivalent fraction with the same denominator. We'll do that by multiplying. Okay, pause the video for a second. Make sure you have this section written down here, some notes, and then I'll give an example. Okay, but what if you don't have common denominators, such as if I take 10/12 and I subtract 1/3? 12 and 3 are definitely not the same, so we're going to have to make a conversion here. What I do know is that 3 can be multiplied by some number to make it 12. So I'm going to take a second and convert 1/3 into an equivalent fraction that has a denominator of 12. And I can do this by multiplying by 4. Whatever you do to the denominator, you have to keep it balanced and do to the numerator. Okay, so it'll be an equivalent fraction. 1 times 4 is 4, 3 times 4 is 12. 4/12 means 1/3. They're exactly the same, but this one's not reduced. They are equivalent. And then if you subtract these, now that they have a common denominator, 10/12 minus 4/12 we can do. Okay, so you do 10 minus 4 is 6 over 12. Because what this really says is I have 10/12, I take away 4/12, how many 12ths do I have? And as always, if you can reduce the fraction at the end, you should. I know that 6 and 12 is the same as 1/2 because you can divide both by 6, and that would be your final answer. Okay, so that's a review of how you subtract or add fractions with just integers. Let's go ahead and try some with rational expressions, realizing that the process is exactly the same, even though they're a little bit less friendly looking. Okay, number 1, we have r plus 6 over 3r minus 6, and we're subtracting 2r minus 1 over 3r minus 6. The good news about this one is they have a common denominator, so you don't have to convert either of them to be a common denominator. Okay, so all you're going to do then is you are going to subtract the numerators, which would be r plus 6 minus, I'm using parentheses for a reason here, but go ahead and write this down with me, over the common denominator, which is 3r minus 6, right? Just like I did 10/12 minus 4/12 is 6/12. So it's this minus this over the common denominator. Okay, the reason I put this in parentheses is because you need to subtract all of the second fraction, both parts, the 2r and the minus 1, not just the 2r. So please use parentheses just like when we did polynomial operations to make sure you get that in, which would make this r plus 6 minus 2r, and then you subtract a negative here, it's actually plus 1 over the denominator stays the same. It's just 3r minus 6. Okay, now you can combine like terms to clean this up. So you have r minus 2r, which would be negative r. You have 6 plus 1, which is 7, over 3r minus 6. And you would want to try to simplify if you could. You could factor these and see if anything cancels. In this case, you really can't factor them further. So I'll tell you nothing else can be simplified. You'll just circle that as your final answer. Okay, so same process, even though there are variables. You want a common denominator, and then you add or subtract the numerators. Okay, number 2, we have 3 over x plus 7 plus 4 over x minus 8. Looks fairly simple, but unfortunately in number 2, I'm giving you an example of what happens when you do not start with a common denominator. So we are going to need to convert these to have equivalent fractions with the same denominator. Okay, now in this case, I can't just look at one of them and say, oh, if I multiply this one by 2, then it'll be the same as the other one. It's a little trickier. It's actually more of a case like, I don't know, let me give a numerical example first and say, what if you had 1/2 plus 1/3? You can't just multiply 3 by something to get 2 or vice versa. So what you would normally do here is say, I can multiply the denominators together, multiply 1/3 by 2, multiply 1/2 by 3 to make a denominator of 6. So you'd then have 3 6 plus 2 6, which you could finally say is 5 6. Okay, if you're not sure what to multiply by, the easiest thing is to multiply the denominators by each other. So in this case, x plus 7 needs an x minus 8. Whatever you do to the denominator, you have to multiply it by the numerator as well. And the x minus 8 needs an x plus 7 to be common. And you have to do that to the numerator as well. Okay, so that's the process we're going to go through, similar to the number example. And just to clean that up here, we're doing 3 and multiplying it by x minus 8 over x minus 8 times x plus 7. You can leave it in factored form, make it easier. And to that, you're going to add 4 times x plus 7 over the same denominator, x minus 8 times x plus 7. And now these fractions have the exact same denominator because you multiply them by each other. Once they have the same denominator, all you have to do is add the numerators. So for the sake of room, I'm going to rewrite this as one fraction. Okay, you're really just going to add the two numerators together over the common denominator, which don't erase on your paper, just write it down. And so common denominator again was x minus 8 times x plus 7. Okay, in this case, you cannot leave this as a sum and circle it and say it's your final answer. You also know that you cannot cancel these. Kind of defeats the purpose of getting it in the first place. But the reason you can't cancel them from the previous video is because it's separated by a plus sign, right? That's not a product. So you cannot cancel here. Okay, all you can do to go and clean this up is do the calculations. So we are going to multiply this out, and then add them together. Okay, so you'd have 3x, let's see, 3x minus 24. And to that you're adding 4 times x is 4x. 4 times 7 is 28. All over x minus 8 times x plus 7. Just clean up steps once you combine them into one fraction. Combined like terms, you have 3x plus 4x is 7x's. You have minus 24 and positive 28, which would give us plus 4 over our common denominator, which you can totally leave in factored form. You do not have to multiply that out. Might as well take the most efficient final answer. Since this can't be factored any further, none of these are common factors, you can't cancel anything, and that is your final answer. Okay. Now, sometimes if these denominators are fully factored, it's a little bit easier to see. But sometimes it's easier to get a common denominator than just multiplying them. For example, when I look at number 3, I notice 4x plus 12 is not in fully factored form because you can factor out a 4. So if I factor out a 4, this becomes 4 times x plus 3, which, hey, there's an x plus 3 in the other denominator. They're very close to having a common denominator. The only difference is this one has a 4 and this one doesn't. So in order to give them a common denominator, all I have to do is multiply that one by 4. But if I multiply the bottom by 4, you'd have to go and multiply the top by 4 as well. Okay, so the common denominator is 4 times x plus 3. The numerators then are 7n minus 4 times this. I'm going to write it that way. Okay, you can switch around the order because 2 times 3 is the same as 3 times 2, right? And if you clean that up, we can get our final answer. So what I'd like you to do right now is do the expression simplification in the numerator. Pause the video, I'll come back with the answer. If done correctly, you should have got minus 5n minus 8 in the numerator. Over the common denominator, we can just leave like this. There's nothing that can be simplified because there's no common factors, so you just circle your final answer. Okay, the point that number 3 and also number 4 will bring up is you do want to factor when you can in the denominator to make sure they have common factors. You can see the common factors like this one. Also, this one is supposed to say y. We'll just go ahead and change that right now. So what I'd like us all to do is factor this denominator, factor y squared minus 1. Okay, come back with the answer. I want you to try that on your own, and we'll see what common factors each denominator has. Okay, if done correctly, the first fraction, denominator, factored form, y plus 4 times y minus 1. Y squared minus 1 is a difference of squares, which would be y minus 1 times y plus 1. Now, why did factoring the denominator help us here? I'm hoping you're seeing that they actually do have a common, not a common denominator, but they have a common factor in their denominator of y minus 1. Okay, the only thing that needs to happen is that the left fraction also gets multiplied by a y plus 1. Whatever you do to the denominator, we'd have to do the numerator. And then this fraction is missing a y plus 4. So we would multiply the denominator by y plus 4 and also the numerator to make those be the same, which would make the common denominator have 3 factors of y plus 1, y plus 4, and y minus 1. Had we not factored the denominator, we would not have seen that they had that common factor. We wouldn't have known they already have a y minus 1, so we might have double accounted for it. Okay, just to rewrite the numerator, you have y minus 1 times y plus 5. And I'm just writing this in one step because you know that once you have a common denominator, you just add the numerators. So we're going to be adding that to y plus 2 times y plus 4. Okay, that is our combined fraction. Obviously not in the cleanest form. We could simplify this, but that's the general idea here. Okay, again, I'm repeating myself, but this is so important. Once you get here, you cannot cancel common factors because there is a plus sign between them, right? I cannot cancel these y plus 4s. If you're not sure why, go back and watch video number 1, I believe. Okay, but it's because there's a plus sign here. So all you can do is multiply these together and then add them, right? That follows our PEMDAS order of operations, where you would multiply these guys together and you'd multiply these guys together and then you combine like terms. So I want you to try that. Clean this numerator up on your own. I'll do the same and I'll come back with the answers in a second. Try on your own though, no peeking. Okay, if cleaned up correctly, you are going to have your final answer of 2y squared plus 10y plus 3 over the same common denominator as before. I know that this looks like a lot of algebra, a lot of work, but it's really not so bad if you take it bit by bit. So first, I just double distributed each of these things to get me here. And I just cleaned that up in the next step. So 5y minus 5 gave us this like 4y here. And 4y plus 2y gave us this 6y here. And then I just added these together. You combine like terms. Y squared plus y squared is 2y squared. Right? You're just cleaning up the numerator, trying to add those together since they already have a common denominator. Okay, if you have questions about any of the previous skills, such as polynomial operations, double distribution, factoring, definitely come and see me. Otherwise, that is how you add fractions or subtract fractions. Or when you apply to fractions with variables, it's not too different. So, hope you learned something new and have a good rest of your day.